Good evening, and thank you, Joshua and Bridger, for inviting me to present some archaeological information, which, as you mentioned, I presented at the Society for American Archaeology meetings last year, and also the Northwest Anthropological Conference. And as you also mentioned, an article has recently come out in the Journal of Northwest Anthropology on the same topic. This presentation is primarily about evidence that Ice Age hunters killed a Pleistocene horse about 13,000 to 16,000 years ago. These Pleistocene horses became extinct in North America shortly thereafter. It's based on a report that was prepared for Public Utility District Number 1 of Chelan County. Pleistocene horses died out at the end of the last ice age about 12,700 years ago, probably during the period that's called the Younger Dryas, which was the last cold pulse of the ice age climate, during which time temperatures dropped 2 to 3 degrees Celsius or 4 to 5 degrees Fahrenheit. They had been warming, and then there was a sudden extra push of pulse of cold climate, and that may be when these animals went extinct because of those climate changes at that time. There were Native American people here at that time during the last ice age, and they hunted a variety of animals that are now extinct, including mammoths, mastodons, camels, and horses. These animals died out at the end of the Pleistocene due to warming climate that changed the environment to which they were adapted, and possibly due to predation by humans who are relatively new on the scene. The Pleistocene horses survived on other continents, but not in the Americas. Horses were later reintroduced to the Americas by the Spanish conquistadors more than 12,000 years later. Nobody really knows what Pleistocene horses actually looked like, although paleontologists have done some reconstructions. For fun, I asked one of those new artificial intelligence programs to illustrate a Pleistocene horse for me, and this is what I got. I don't think it's really very accurate, as it looks like a modern horse with stripes against a foggy or misty background, which probably represents the Pleistocene or Ice Age as the mists of time. So this evidence comes from near Wenatchee, the apple capital of the world. So I've used an apple symbol to represent where Wenatchee is in the state of Washington on this map. And the archaeological site that we're talking about has a Smithsonian trinomial, which is a system of numbering archaeological sites used across the country, such that the first 2 digits of the number, the 45 in this case, represents the state in which the archaeological site was found. So if you put all the states in alphabetical order, Washington is the 45th state. So the 45 in this number represents Washington. The CH represents Chelan County, and the 204 represents the 204th site, archaeological site, that was recorded in Chelan County. And the site is located along the Columbia River south of Wenatchee. When it was originally found, it was not thought to be particularly old, but recent reanalysis of the artifact shows that it dates to between 13 and 16,000 years ago, which is older than the East Wenatchee Clovis cache, for which every archaeologist in North America knows the Wenatchee area. With the new information about another very ancient archaeological site in the Wenatchee area, we may need to start saying that Wenatchee is the ancient archaeological site capital of the world, in addition to the apple capital of the world. But that doesn't fit on the road sign very well, probably. So archaeological site 45CH204 was originally discovered in 1974, and archaeological excavations took place there in that same year, as shown in these black and white photographs. A crew from Washington State University conducted the excavations, led by graduate student Derek Valley. I don't know if the person tracing stratigraphic layers in the sidewall of the excavation at right is Derek Valley, but I'm guessing it might be. Please note that he's crouching on a cobbly layer at the bottom of the excavation. We're going to come back to that in a minute. we're going to come back to it right now. In total, WSU excavated 84 square meters in shallow wind-blown sediments over Pleistocene flood gravels. So I'm going to see if I can get my pointer to work here and point out these Pleistocene flood gravels are these rocks here at the bottom of the stratigraphic profile of the excavation unit that was dug. So this up here represents the sediments that contain the archaeological deposits. And then down here is what we think is Pleistocene flood gravels from the end of the Pleistocene. So massive floods at the end of the Pleistocene ripped through this area, stripping sediment down to the bedrock and leaving gravel deposits such as these behind. This is the floor of the excavation unit that's above. And these floods ended about 15,000 years ago. So we think this gravelly stratum at the bottom of the archaeological deposits represents a period about 15,000 years ago. The WSU excavations recovered over 1,500 stone tools, such as these bifacial blanks, knives, projectile points, and I want to point out these projectile points down here at the bottom. These are what's referred to as Windust style points after another site lower on the Columbia River called Windust Caves. And these are distinctive for the broad stems and these little shoulders right here on the bases of the projectile points. And this one's broken, but these two give you an idea of what the complete one would look like, although they've been reworked a bit. There was also some drills and scrapers. So those are other artifacts represented in this photograph from the 1974 report. There was also a huge amount of debitage or flakes. These are a byproduct of making stone tools, and they're recovered at the site. The abundance of these recovered at the site made the WSU report say that they thought this was a lithic workshop, meaning a place where stone tools were made. In a slim report on the results that Derek Valley put together, he also suggested that the site was occupied between 2,000 and 7,000 years ago based on typological assessment of the projectile points. This assessment is a little bit puzzling, but the Windust type points were not well recognized at that time. In the early 70s, they had just really been defined at that time. And these points are now known to date from about 11,000 years ago to 13,000 years ago, or possibly even older. So now we shift from the 1974 results to recent reanalysis of the artifacts from those earlier excavations. If you're not familiar with the term debitage that I used previously, or flakes, here's a short video showing how a flake or piece of debitage is created in the process of making stone tools. I'm going to play this video. And this is me working on an Obsidian percussion bifacial blank to thin it out. And I'm getting prepared to remove that high spot that I just abraded. And then I'm abrading the edge here, and then I'm going to take a flake off. And that flake comes off the bottom side. I caught it in my fingers there, and you can see the flake that was removed. That's a flake or a piece of debitage. And you can see on the ground there next to my feet other flakes and debitage, and I'm dropping another one on the ground there. So you can see that a lot of this is accumulated in the process of making stone tools. So we use the abundance of those flakes as a proxy for how much flint knapping activity was going on at different times during occupation of the site. The debitage or flakes were never analyzed by WSU. So recently, a sample of the debitage, 504 flakes from one of the WSU excavation units, was analyzed by our company, AI&W. The analysis showed that most of the debitage was recovered from deep in the excavation. And this graph here shows the excavation vertically. So the bottom of the excavation is represented by these bars down here at the bottom. and then the top of the excavation is here. And the law of superposition says that things are at the bottom are going to be older and things at the top are going to accumulate later in time. So we think that this represents the occupation of the site from the time it was first occupied until it was abandoned. And you can see that these bars are different heights because they represent the amount of obsidian debitage found in each 10 centimeter or 4-inch thick level that was excavated. And you can see that there were 111 flakes found in this level, which is more than the others. So, and this is towards the bottom of the excavation. This is the bottom of the excavation here where those gravels were. And just after the beginning of the occupation, there was a fluorescence of flint knapping activity represented here. So what this is telling us is that most of the flint knapping or work that was done to create these stone tools occurred early in the occupation of the site. And we also did a technological analysis. So by looking at the flakes or the debitage, we can tell what type of reduction was happening and how the stone tools were being made. So we did an analysis of the flakes or debitage, and we found that towards the bottom of the excavation, larger flakes were in higher proportion. There were also more basalt or andesite flakes, both of which are characteristics of early assemblages of archaeological materials on the Columbia Plateau. And the technological analysis also revealed that over half, or 53%, of the technologically diagnostic debitage was from percussion bifacial thinning, from making bifacial blanks like the one was shown in the video that I showed just now. That there were more late-stage percussion bifacial thinning flakes, meaning that there was more emphasis on thinning bifaces systematically, which is also characteristic of these early assemblages on the Columbia Plateau. So we also brought some heavy-duty science into this reanalysis. One of the scientific methods that we used is called obsidian source identification. And obsidian is a type of rock used to make stone tools and is also a volcanic glass that forms during volcanic eruptions of certain types of volcanoes. There are very few obsidian sources in Washington, and the Washington sources tend to have smaller sized pieces and are generally of poorer quality. However, in Oregon and Idaho, there are over 100 sources, and some of them are of high quality for making stone tools and occur in large enough pieces to make most of the types of stone tools that are found archaeologically in the region. When obsidian artifacts are found in Washington, they can often be traced to Oregon geological sources. One of the characteristics of obsidian is that the volcanic sources have trace element chemicals that are distinctive to each source. Therefore, by using X-ray fluorescence to identify the abundance of trace elements, such as strontium or yttrium, a particular artifact found anywhere in the world can be traced to its geological source. Northwest Research Obsidian Studies Laboratory in Corvallis characterized the obsidian found at 45CH 204. So there were 6 artifacts representing all of the available volcanic glass from the site that was of adequate size for this analysis. And these were selected for X-ray fluorescence. One flake turned out to not be obsidian. That's this one right here. It was instead a glassy volcanic tachyllite, which is actually available locally in the Wenatchee area. The most distant obsidian source identified was from a flake from the Coghlan Butte source, which is this source right here on the map. And Coghlan Buttes is 457 miles as the crow flies from Wenatchee, or the site at 45CH 204. So it's a long distance from from the source of the obsidian to where the obsidian artifact actually ended up deposited archaeologically. And so what this means is that people either traveled to Coghlan Buttes to get the obsidian to make their stone tools and then discarded them up here, or that the obsidian was in a trade or exchange network, which was pretty abundant along the Columbia River. And there were lots of trade fairs and opportunities for pre-contact people to get obsidian from people that lived in this area down here. So they didn't necessarily have to travel all the way down here to get the obsidian, but they might have traded for it with people along the Columbia River. The next most distant source is in Idaho. It's called Timber Butte, and it's 419 miles southeast of the site. And then we have Cougar Mountain here, which is 391 miles from 45CH204. And the closest site, El Dorado here, is still 323 miles away from the site. So this material traveled a long distance before it was finally deposited at 45CH204 in the form of artifacts or flakes from making artifacts. AINW has developed a model for estimating the ages of obsidian artifacts based on obsidian hydration rind measurements. And I'm going to talk a little bit more about that in the next slide. Obsidian hydration dating is based on the fact that obsidian absorbs moisture from the air around it to form a rind at the outer surface of the obsidian. When a fresh surface is exposed to the air during flint knapping, like during the video that I showed you, that fresh surface starts to form a rind that gets thicker over time. This slide shows a thin section of an obsidian artifact through a microscope, and the rind is represented by the dark band right here. So again, we're looking at a very thin section of an obsidian artifact. The artifact is over here. This is not the artifact. This is the slide that it's mounted onto. And this is the hydration rim or rind that's developed over time, this dark area right here. And the analyst uses a micrometer as they're looking at the slide through a microscope at the very small section of the edge of the artifact. And they're able to use the calipers or the micrometer in the microscope to measure the thickness of this rind. In this case, the rind was measured at 3.865 microns, which for comparison, the diameter of a human hair is about 60 microns. So that would be wider than the entire width of this slide at this scale. So we're talking about very tiny things that you can see through a microscope when you cut out a little notch of the artifact, grind it down so it's real thin so you can see through it, and mount it on a slide and measure it through a microscope. And as I mentioned before, that thickness of the hydration rind increases over time. And so it increases at rates that we can calculate. And so we can use the rate of rind thickness increasing to estimate the age of the artifact. So if we go back to our obsidian artifacts from 45CH204, we were able to estimate the age of the El Dorado obsidian artifacts, which is the only source for which we have a reliable rate amongst the ones that were represented at the site. One of the El Dorado artifacts dates to 12,412 years ago, and there's a plus or minus on this age estimate, which indicates it's not very precise, because the plus or minus on this is 2,879 years. So that equates to a range of between 9,500 and 15,000 years ago. So it's a pretty broad range, and it's not a very precise way to estimate an age, but it does give us an idea that these are old artifacts. And this other El Dorado artifact gave us an age of 16,568 years, plus or minus 3,575. So again, not very precise, but again, also telling us there's potentially significant antiquity to this site by the estimation from this process, in addition to the other things that I talked about earlier. Another way to look at the hydration data is to compare them with previous obsidian hydration rime measurements from the same sources of obsidian. So Pips Thatcher of Willamette Analytics, who made the measurements, compared them with all the previous measurements from other archaeological sites throughout the region in the lab's database. Pips provided these data that are represented in the graph here. So for the El Dorado source here, there were 26 previous hydration rime measurements on artifacts in the lab's database. They range from 1.1 microns to 5.1 microns. And so all of the other artifacts that had been measured previously were in that range. When they measured the artifacts from 45CH204, they were 5.2 and 5.8 microns. So literally off the scale of age for previous artifacts in the lab's database. Pips did the same thing for Coghlan buttes, of which there were 56 in the lab's database from other archaeological sites. And the highest measurement was 6.7 microns, which would be the oldest artifact in the database. And we had 7.3 microns from 45CH204 in the Wenatchee area. So again, off the scale in terms of previous knowledge of the age of artifacts in the lab's database. For Cougar Mountain, there were 175 artifacts in the lab's database that had hydration rime measurements. They ranged up to 8.9 microns. The artifact from 45CH204 was 8.5 microns, so not off the scale like the other ones, but still at the old end of the scale, very close to that. And then finally, Timber Butte, 92 readings in the lab's database. The highest one was 5.3 microns. From 45CH204, we had 5.7 microns. So this is also telling us that we're looking at very old artifacts here. We have to, I have to note that these comparisons are done without the data being corrected for effective hydration temperature for archaeologists that might be in the audience and might be wondering about that. But still, it's giving us a good sense of the age of these materials. Next, I want to talk about protein residue analysis that we conducted to see what the tools from 45CH204 might have been used for. The test identifies different animals based on their blood or other proteins in immune reactions, and this technique was first used in forensic science by the Royal Canadian Mounted Police. For its application in archaeology, we can all appreciate that stone tools used to kill or butcher animals would get coated with blood and other proteins, like is shown in this experimental butchery experiment here with a stone obsidian knife. But the big question is, how can these protein residues persist over thousands of years on stone tools when they're buried underground, when many other organic materials decay and are unrecognizable in the same conditions? Well, the key is that while stone tools appear to be smooth and non-absorbent, tool use often introduces proteins into the tiny cracks and pores that are only visible under high magnification. So here's that high magnification of a microscope image of a piece of chert, which is the kind of tool stone that a lot of artifacts are made out of. And you can see the microscopic cracks into which the proteins and fatty molecules are absorbed through capillary action and become trapped in those cavities and crevices. A researcher at Oregon State University has shown that blood that gets drawn into these cracks, that blood does get drawn into these cracks, and that fat that's associated with it can decompose into a waxy substance that protects the proteins from microbial decay. So that's one of the big questions that was brought up early on in this kind of analysis, was how do those organic materials get preserved for thousands and thousands of years? And our lab has shown that it is possible. So preservation of identifiable mammoth blood cells has been preserved in fluted projectile points that are 12,000 years old. One of the distinctive things about mammoth blood cells is that they're big. You can see in this slide a comparison of the diameter of a mammoth blood cell compared to the diameter of a bighorn sheep blood cell compared to the diameter of a bison blood cell. And you can see how the size of the animals corresponds pretty well with the size of the cells in their blood, which I had no idea about before we started doing this. So some artifacts have been found in Alaska where that were more than 12,000 years old, and they could actually see the preserved blood cells on those artifacts. But detecting them is a little bit easier using the technique that I'm talking about. We've also detected rhinoceros proteins on 275,000-year-old stone tools from Jordan in our lab. So preservation and detection of very old proteins has been demonstrated. Immune reactions are the way animals protect themselves from diseases. Mammal blood can fight off invaders by developing antibodies that react to foreign antigens by bonding to them using their specific structures to latch onto, after which they precipitate out and are eliminated as waste. Antibodies that develop are specific to the invading antigen for certain animals. And animals in the same taxonomic family have the same types of antigens. So when the same antibody will react to foreign proteins from that taxonomic family. Therefore, antibodies that react to foreign elephant proteins will also react to foreign mammoth or mastodon proteins because they're in the same family, the same taxonomic family. So in this way, we can use modern and domestic animals to test for residues from their wild or even extinct cousins. There's several steps to the analysis done in our lab. The first step is to select an artifact to test. Then we extract the residues by putting them in an ultrasonic bath that loosens them up from those cracks and crevices and gets them to come out in a solution, which is then inserted into an Argos gel with paired wells in the gel. And this picture here is of our residue analyst, Cam Walker, preparing the gels for the analysis. So here he's pipetting those residues extracted from the artifacts into these wells that are used to make them react with antigens and antibodies in paired wells. So the way it's done is to put it into the Argos gel wells, and then electrical current is drawn across them to make the contents of those wells interact with each other. And that process is called crossover immunoelectrophoresis, or CIEP for short. So once that is done, the Argos gels are blotted, left to rest overnight, then they're rinsed and blotted again, and then stained blue to view. And they look like this when that's done. Here's a photo of the gels in the CIEP machine. So this is the machine here. These are the gels with the paired wells in them. We do a whole bunch at a time here. And then when they come out of the machine, they're dyed. So this is the dyed gels. And this is a close-up view of the gels that are being read on a light table. And what we're looking for on the light table is a line like this between the paired wells. And what that's showing us is that there's a precipitate that's formed from the interaction of the contents of these two wells. And as it migrates through the electrical current, drawing it across there, it precipitates out and forms this line. And so when we get that line, we know that there's a positive reaction. So if this well had the antigen for horse, and this well had the antibodies that were, I'm sorry, the antibodies would be here, and the antigen from the artifact in here, then when we get this line, it's telling us that that's a reaction between horse and the residues that were in the artifact. I know this is complicated, so I'm happy to talk about it more after the talk if there's questions. So we analyzed 5 artifacts from the Rock Island Overlook site. And this is 3 of those artifacts. We tested all of the artifacts that we tested against anti-sera for deer, trout, horse, elephant, cow, sheep, and goat. And if you recall, these are proxies for the same taxonomic families from native species. So, for example, a cow here is used to test for bison, and sheep for bighorn sheep, and goat, domestic goat, is used to test for mountain goat. So we tested for all these different kinds of animal residues that might be on these artifacts, and this knife and this knife and this projectile point had no reactions to any of those. So we struck out on those 3 there. But this one did react to trout antiserum, which likely represents salmon given its provenience near the Columbia River, where the artifact was found. And while we don't know, I don't know what a scraper, this is a scraper here. This is 4 different views of the scraper. So this is the working edge of the scraper here, commonly used for scraping animal hides. And this would have been the hafted end of it up here. So it's usually hafted onto a handle. And this is a cross-section view here of this surface here. And this is the ventral view of the same flake that it was made on. So, like I said, I don't know what a scraper might have been used for to process salmon, but a native person told me that they were possibly used to scrape skin, the salmon skin, possibly to make glue or mastic that was made out of the skin of fish, and could have been used even to haft this particular scraper. So this tool might have been used to scrape the salmon skin, or it might have been used as part of the mastic to hold the scraper onto the handle. We just don't know that. The Windust projectile point tested positive for horse blood. As I mentioned earlier, Spanish horses were first introduced to the Columbia Plateau in about AD 1720, or some people now think it might have been as early as the AD 1600s. But before then, there were no horses on the plateau since the end of the Pleistocene. Those Pleistocene horses went extinct in the Americas about 12,700 years ago. So Windust points like this are thought to date between about 11,000 and 13,000 years ago or older on the Columbia Plateau. The site where it was found at 45CH204 appears to date to the late Pleistocene, as described earlier in this presentation. These data suggest that the Windust point was used to kill a Pleistocene horse rather than the much more recent modern horses that were introduced to North America by the Spanish. Archaeological site 45CH204 here on this map is not the only site where evidence of Pleistocene horses hunting has been found in the region. So a little orientation on this map. This is not the usual map that you see of the Pacific Northwest. That's because this represents what the landscape would have looked like about 16,000 years ago during the last ice age, when there were these giant ice sheets, glacial ice sheets covering large portions of the land. And because there was so much ice and water on the land, the ocean levels went down. And so the coast was way out here compared to where it is now. The other thing that this map is showing is Missoula floods. That's what the MF stands for. These are Pleistocene floods, about 40 of them that occurred during the end of the last ice age as ice dams broke and waters flooded down through the Columbia River drainage all the way down out to the ocean here. And on the way, they stripped out a lot of the sediments and left behind the gravels that I illustrated in some of the earlier slides at the bottom of the archaeological excavation. So the most notable other site that contains evidence of Pleistocene horse hunting is this site called Wally's Beach, which is in southwestern Alberta, Canada. Here there were 7 butchered horse skeletons found in association with stone tools. The stone tools were bifaces, flake tools, and a chopper. And a radiocarbon assay of the collagen from the horse skeletons at Wally's Beach was used to estimate the age of the skeletons to be about 13,300 years ago. Evidence of Pleistocene horse hunting has also been found at other Pleistocene age archaeological sites, including this one down here in southeastern Idaho, which is called the Wasden site, which contains Owl Cave. And at Owl Cave, there was horse blood detected on a Folsom type projectile point, which is another early type of projectile point that was probably a little bit later than the Windust points found up here in the Wenatchee area. At Cooper's Ferry, here in western Idaho, along the lower Salmon River, a Pleistocene horse tooth fragment and other likely Pleistocene horse bones, along with lithic artifacts, were found in a pit feature dating to between 14 and 15,000 years ago. Pleistocene horse bones and protein residues on artifacts were also found here at Paisley 5 Mile Point Caves in association with other Pleistocene megafauna, human coprolites, artifacts, including Western stem tradition projectile points. So the Western stem tradition projectile points are similar to the Windust points found at 45CH204. So to summarize, new data from the Wenatchee area shows that ancient Native Americans used a Windust type projectile point used a Windust type projectile point to hunt Pleistocene horses. And this supports a growing body of data that Native Americans were here much longer ago than we previously thought, and that horses were perhaps a staple in the diet of the first Americans. So there's very little data here. This represents all of the data that's known from this large area here. You know, this is pretty important that this was found in the Wenatchee area for archaeologists. So many people helped with this project. In particular, I would like to thank Jennifer Burns and the Chelan County Public Utility District who supported this work. Also Guy Mora and Jackie Cook of the Confederated Tribes of the Colville Reservation, who suspected that 45CH204 had more to tell and supported scientific analyses of the artifacts. I also want to thank Jason Cowan, Cam Walker, and others at Archaeological Investigations Northwest who helped with this project. Finally, at the beginning of this presentation, I showed an artificial intelligence rendering of a Pleistocene horse, which was probably not very accurate. So I tried a few more times, and I got some surprising and amusing results from trying it again. This one shows what I like to call the Disney on Ice version of a Pleistocene horse. This one seems to be some crazy cross between a mammoth and a horse. And this version, if it's accurate, may illustrate why Pleistocene horses went extinct in the first place, having no heads and 5 legs. That's all I have. Thank you very much, and I'm happy to take questions.
Thank you, Terry. That was great. And again, folks, you're welcome to type questions into the Q&A, and we can ask those to Terry. So one, and I think Terry, you may have already answered this question, but I'll go ahead and ask it anyway. What were the materials that were present in the Debitage? That was the Obsidian. Is that?
Yeah, there were not very much obsidian, actually. There were only about 6 pieces that were large enough to do the X-ray fluorescence analysis that I talked about, to trace it to the geological source of the obsidian. Most of the materials were a basalt or andesite in those lower levels that represent the earliest occupation of the site. And there were also chert or flint, which we lump together and call CCS or cryptocrystalline materials. That was probably the majority of the different material types. But there was a close second was the andesite and dacite from the lower levels.
And then we had another question here that says, how narrow is the distribution of blood cell size within a certain species? And they said they were surprised to see the ability to distinguish between species for blood cells of similar size, like elk and bison. And so it sounds like, if I'm reading that correctly, it's like, how come a really large elk wouldn't have overlapping blood cell size with perhaps a smaller bison?
Yeah, good question. So we don't, when we do the blood residue analysis, we don't use the size of the cells to identify the type of animal it is. I was just pointing out that it was interesting that you can actually see how the size of the cells differs by the animals. But the test actually tests for that antigen antibody reaction. So we don't actually see the cells. We only see the results from them precipitating out on those Argos gels that I illustrated. And so it's a matter of the reaction of the antigens and the antibodies, which fit together in a very close way because they're developed specifically in the bloodstream to counteract those foreign invading cells. And that's the basis of the identification. It's not the size. I just thought the size was interesting.
Terry, I have a question here, little technical, but have you explored the possibility of employing proteomic techniques to validate and or explain immunological based assays of protein residue on stone tools?
Well, I don't know what that word means, proteotechnic. So I don't think we have, but I don't know what that means.
This person who typed that in, you're anonymous, but if you want to ask that question again, maybe. Proteomic, yeah, I'm not sure what that is, but thought I would try it, give it a...
It sounds like it's based on the word protein. So it may be the same approach that we're using. I'm just not sure. The other way that a lot of people do analysis of residues like this is by extracting DNA. And that's a much more complicated process. And we don't do that in our lab. And it's, there's a whole big area of ancient DNA studies that archaeologists around the world are doing, but we don't do that. And I support it, but we don't do that ourselves.
And then we have a question that's asking about the range of size for projectiles that Native people were using. You have a sense of, can you give us with your hands?
Sure. Well, a lot of the projectile points that were used with bows and arrows later in time are tiny. They could just be less than an inch long. Some of the more ancient artifacts tend to be larger. That's not a systematic relationship between age and size, but a lot of the larger pieces, larger artifacts come from the earliest time periods. And it's just a factor of what kinds of weaponry or tools they were being used with. So the largest projectile points can be quite large. I don't know if you can see my fingers there, but I think 30 centimeters or a foot about is, some of the larger pieces. There was a Clovis point from a private collection in the Wenatchee area that was about, I want to say, close to a foot long. And it was made of obsidian, which is very unusual, for an obsidian piece that large to make it all the way up to Wenatchee, probably from Central Oregon.
Terry, can you maybe more in general terms, can you tell us a little bit just about the archaeology in Washington? Maybe what are some major questions that people are asking from archaeology?
Sure. Well, one of the hottest topics right now is the peopling of the Americas. When and how that happened. And a lot of the tribes believe that they've been here since time immemorial and that they did not arrive through migration, but they were always here. And then a lot of the dating for archaeological sites, previously the archaeologists until the probably mid 1990s thought that the oldest materials were Clovis materials, which were about 12,000 years old. And now we're finding artifacts that are 16,000. There's some evidence for even earlier people coming to the New World or the Americas. You may have heard about White Sands in New Mexico, where there were footprints actually found in those sands. And they've been trying to date those footprints. And the best dating that's come out so far suggests that they're probably 23,000 years old. So that's way older than, what we had thought before. There's a site in California called Cerruti that some archaeologists think is 130,000 years old. Some of those people are crackpots, but there's all kinds of evidence that archaeologists try to evaluate to try to get at this question of when did people first arrive here and where did they come from and what were they doing? And, so that's one of the big questions, and that's kind of the topic that I was talking about tonight. There's lots of other questions that archaeologists are trying to answer about how people lived, what kinds of technologies they had, where they traveled, what foods they ate. There's just all kinds of questions that archaeologists have. There's about 40,000 archaeological sites in Washington state, and they range from, these really old sites like I was talking about up until recent sites. Some sites are known to be important even before they get to be 50 years old. Like, for example, the Twin Towers at Ground Zero in New York City has already been determined to be a historically important site, even though it's, relatively recent since that happened. And historic period archaeological sites are being focused on more and more in Washington state and throughout the country because there's information from the archaeology that people don't necessarily get from written histories. Because as we all know, histories are written by the victors of battles and by people who are predominant in the society. And so to get the perspective of to get other perspectives from people that were not dominant in the society, we can look to archaeology to answer some of those questions that were not written down in the histories.
We have a question here that's asking, what do we know about horses in other parts of the continent? You'd mentioned, that it was a small but growing body of evidence. Does that evidence spread outward from?
No, it
here as well?
doesn't, not as far as I'm aware of. There's probably a few other places. But most of the data that I'm aware of comes from the Pacific Northwest. I think there are others though. I'm just trying to think of what they are. I think there's some evidence from North Dakota and probably some from Florida. But I'm not familiar with all of that data. Yeah, was that the answer to the question?
Yeah, I think so.
Okay.
I have a couple of questions about the obsidian. One was, did the interior plateau get most of the obsidian from Oregon, in your opinion? And then while you're talking about obsidian, why are the error ranges for the hydration dating so large?
Yeah, those are good questions. Yeah, obsidian that's found at archaeological sites in Washington State most commonly comes from Central Oregon, because that's where most of the obsidian is in the region. Like I said, there's a little bit in Washington, and some of those sources were used pretty abundantly in their very local areas, but because the pieces are generally small and not of as high a quality as some of the Oregon obsidians, it didn't tend to get traded around as much. So we see a lot of obsidian from Oregon in Washington. There's also some from Idaho and a little bit from Washington State itself. The error ranges for those dates from obsidian hydration are because this is a method that's being developed now. And our company is leading that development, I believe. And we are gathering data as we go. And as we get more data, we expect that error rate or the confidence interval of the dates to get narrowed down. So as the science progresses, I expect we'll get more and more precise dates.
And then was there a particular reason that Rock Island was excavated? What sort of tipped us off for that site?
Yeah, so most of the archaeological work that gets done in the world and in the country and in Washington and in Chelan County is done because there's some development that's going to impact that archaeological site. So that was the case for 45CH204. Chelan PUD was developing that area and they wanted to use some of that land. And so they had those excavations done in 1974 in order to mitigate the impacts to the site. And then when there were some additional impacts to the site more recently, we suggested doing reanalysis of that collection. And that's where we got this information.